In this example, I'm going to show you how scan data and the MapScenes point cloud software can be used for crash reconstruction. We're going to be doing a damage profile of a vehicle here. The markers that you see on the vehicle, the green dots, in addition to scanning the vehicle, we also mapped it with a total station to get a comparison on how long it took to map it versus scanning it and how long it took to process the data. In this example here, the vehicle wrapped itself around a pole. It's a law enforcement case. We'll take a look at the different photographs here from a different perspective here, and then one that's going to show the depth of the damage here. Here's a view of the damage profile. I'm going to zoom in here, and the blue line is what represents what the total station shot. The red line is the scanner data. You can see the point and a description for each of the shots that were taken. I'm going to turn off the data points from the total station, and we're going to look at just both of the profiles that we have here. Red is the outline that was done from the scanner data. Blue is from the total station, and you can see it's a very good match. Look at the total station data only, and then the scanner data, virtually on top of each other. I'm going to leave them both on for the demonstration here. Just showing you the outline of the car here and how well it lines up. This is the point cloud data here. And let's rotate it around and get a different view. Turn off the line work so that we're looking at the scan data only. You can see the markers show up that were in green are showing up in white here, so that gives us an indication of where the shots were taken to from the total station. Just going to pan around the vehicle here. And you notice that the data is very clean and what I call cropped. We don't need any data that is outside of this box that surrounds the vehicle. We'll take a look at it in a top-down view here in a moment. But when I talk about processing the data before you bring it in, that's what I'm referring to. This scan is about 2.2 million points. It's a daytime scan, so we're able to use the colors from the scanner. And again, here's a top-down view. So in your proprietary software, you want to crop out what you don't need and bring in just the damage profile of the vehicle. Let's look at some of the tools that were used here. This is the cutting cube, which we've demonstrated, and I have a left side and a right side. The reason I have two is, as you gain experience drawing with the program, if I split the car in half, it makes it easier for me to draw on the right or the left side of the car. That way, as I'm picking my points, if I'm trying to draw a damage profile, I make sure that I'm picking only on the right side or the left side of the car, whichever one I have activated, and I'm not going to inadvertently pick a point that I think is going to be on one side of the car, but may shoot over to the opposite side of the car. So again, you cut the car in half. If you wanted to draw your damage profile here, you could go around and trace on the outside from the markers that were in place where the total station took its measurements from. I'm going to show you another tool here that I used. This is called the profile slice. Similar in respect to the cutting cube, but it's going to slice from the bottom up to the top on this vehicle for me. I have the gizmos for controlling it, for moving it up and down, left and right, or lining it. My slice thickness is 0.05, a very thin slice that I want to take out of here. And you can see here in red, that's going to define the plane that I'm going to use to slice through the vehicle. I can move it up or down in this increment here, which is 0.25, just by clicking forward or backward, move it up or down the vehicle and get it aligned to exactly where I want it to be. If I wanted to take multiple slices and come up with multiple profiles at different heights, you could use a tool for that. In this example, I tried to line it up to where the officer took the total station measurements from so we could get a good comparison between the data from the point cloud and the data from the total station. Okay, so at this point I'm going to apply it here. Lock it down to a top-down view, and there you have it. Similar to like an MRI or a CAT scan, we just got a slice at a predetermined thickness. I want my snap-in to be on plane here, and I'm going to show you how I draw the profile here. I'm going to draw in the temporary mode. I haven't shown that yet. I'm going to use a spline segment, which is a curved line. Through. It's best if you zoom in and you're consistent in the points that you're picking. Here we have a white dot here that I could pick that the officer used for his measurements. Come around the front of the car, and I'm just going to stop about there. So this is a temporary line here, and I'm happy with it. I could delete it if I didn't like it, but I'm going to accept it, and it automatically sends it over to the drawing. It's going to be a bit difficult to pick out here because we already have two lines representing the damage profile, but I'll show you near the end of the demonstration where that line was. So I'm going to go into the view mode so that I'm not drawing anymore. Toggle on my line work. There's my profile, and the red shows up the best here. The blue one is there as well. You can see what our measurements were taken from as I drew this. And if you wanted a different slice here, you could move it up or down, a predetermined increment here, and do another tracing of the profile as well. This is a top-down view, and we're looking at a different slice here. Distance traveled up from the original is about 1.25 feet, I believe. Alright, so let's return to the drawing here. Zoom in here and see if we can find our line that we drew. And I've got the red and the blue, which were the lines that I had drawn originally before I started the demonstration, and there's a line in black there. And it, again, depending on where you pick, it's virtually overlapping on the other two lines that we have there. So go into a full view here, and that's going to wrap up this demonstration here.